So today we will start our journey from curl and divergence of a vector field. So curl and divergence of a vector field. So first of all we need to know that what we actually mean by saying curl of a vector field. So for example, you have a vector field F that is like mi plus nj plus pk, and this m n p are actually function of the state variables x, y, z. This is a vector field in R cube where the partial derivatives of the component function exist, and then curl F is a vector field given by curl of F. This is del p del y minus del n del z I cap plus del m del z minus del p del x j plus del n del x minus del n del x minus del m del y k cap. Writing using operator notation, you can remember that the gradient operator, this gradient operator is actually delta equal to I cap del del x plus j cap del del y plus k cap del del z. Then curl of F is nabla cross this is called nabla, okay, nabla cross F, and this is I j k, this is del del x del del y del del z m n p. For example, so gradient of a scalar potential will give you a vector, and curl of a vector will give you again a vector. For example, if your F vector A is zx I cap plus xyz j cap minus y square k cap, then your curl F will be, so what will be your curl F? First use the formula, so del del y of p m n p del del y, so that is minus 2 del del z of n, del del of n means is xyz, so that will be minus xy, so that will be minus y common 2 plus x. Then the jth component, the j cap component will be del del x of p minus del del z of m. So del del x of p means this is 0 and del del z of m means x, so that means minus del p del x. So minus del p del x is actually, what will be minus del p del x? Del p del x will be 0 and plus del m del z will be plus x, so that will be plus x j cap, and then in the last term the k cap, the component or the coefficient of k cap, that will be del del x of n minus del del y by m, so that will be y into z. How? See, del del x of n will give you yz and del del y of m is 0, so it will get, you ultimately will get yz k cap. Now let vector F be a vector field defined over a simply connected region D whose component functions have continuous second order partial derivatives. Then vector F is conservative if and only if curl of F is equal to 0. So this is a if and only if condition. So you have a vector field F. So what does this theorem tells you? That you have a vector field F and it is defined over a simply connected region D whose component functions have continuous second order partial derivatives. Then the vector field F is called conservative. How it, when it will be called conservative? If and only if curl of F is equals to 0. If how to you can prove if? So first you need to consider that F is conservative, and if F is conservative, then you will have some scalar potential or some scalar function such that f will be grad f. Okay, now curl of curl of f means curl of grad f, and if you use this, just put grad f, you just that is you will get this equal to 0. Okay, and the converse is actually you observe from Stokes theorem, which we will discuss later. So here we also get one identity. What is the identity? The identity is curl of grad f equal to 0. So please remember this thing, that if you have a scalar function f, then curl of gradient of f will be 0. Okay, now is the vector field f zxi plus xyzj minus y square k cap conservative? Now you observe that this curl of f is not equal to 0, so your f is not conservative. So your curl of f is to minus y2 plus x I cap plus xj cap plus yz k cap, so f is not conservative. Next, is the vector field f y square z cube plus 2xy z cube j cap plus 3x square xy square z square k cap conservative? How to use it? How to prove it? Whether this vector field f will be conservative or not? Just you need to determine the curl. There is nothing. There is not. This is not a very tough thing to prove. You have your vector field f, you have this y square z cube plus 2xy z cube j plus 3xy square z square k cap. Now you need to show that this f vector field is defined on R cube. So is this vector field is not whether it is or not conservative. So you have curl f, you have I j k, you have del del x, del del y and del del z. Now what you need to do, just determine the curl. So first, how to calculate? See, del del y of 3x y square z square. So del del y, that will be 6xy z square. Del del z, that will be once again 6xy z square. The first component so vanishes. Then I have used here minus sign. So what will be our since I have used minus sign, that will be del del z of y square z cube, so 3y square z square minus del del x of 3x, so that will be once again this x, del del x will be vanish, so 3y square z square, and then ultimately plus 2 plus twice y z cube. So next you need to calculate del del x 2x y z cube minus del del y y square z cube. So del del x of 2x y z cube is 2y z cube, and del del y y square z cube is minus 2y z cube. So all the coefficients of unit vector I, unit vector j and unit vector k, they all vanishes. So ultimately you get a 0 vector, hence f is conservative. In fact, you can determine the potential. I hope that you all know that how to determine the potential, how to determine the potential function, how to determine the function f. So this is grad f. How you can determine? See, this is, you need to integrate it with respect to x, integrate it with respect to y, integrate with respect to z, and then there are some process you need to just like tune the functions accordingly, tune the functions accordingly, and you will get the answer. So here you observe, if you integrate with respect to x partially, you will get x y square z cube. Here x y square z cube if you integrate with respect to y, and then the last part you need to integrate with respect to we need to integrate with respect to z. So finally we will get at it as x y square z cube. Hence f is conservative. In fact, f equal to grad f, where fx is yz is x y square z cube. So here is the name game. So curl of f measure how quickly a tiny pedal at a point in some fluid in a vector field moves around itself. So that means that if there is some tiny pedal at a point in some, if there is a how quickly a tiny pedal around at a point in some fluid in a vector field moves around itself. That means that how quickly a tiny pedal at a point in some fluid in a vector field moves around itself. If curl of f equal to 0, then there is no such rotation of such a tiny pedal. Then if f equal to m I cap plus n j cap plus p k cap is a vector field defined on a domain where its component functions have first order partial derivatives, then divergence of f equal to divergence of f, this is del m del x plus del n del y plus del p del z. The divergence is called the flux or the flux density. The divergence is also called flux or flux density. For example, if f cap equal to zx I cap plus xyz j cap minus y square k cap, then divergence of f is equal to z plus xz. How? Just you are considering del m del x. Del m del x will give you z, del n del y will give you xz, and del p del z from this minus y square will give you 0. So the divergence of the vector, now if you have the divergence is also called the flux or flux density. Now if you have in a vector, if you have only the ith component and the jth component, then the divergence will be del del x of x square minus y plus del del y of xy minus y square. The answer is 3x minus 2y. Intuitively, divergence f measures the tendency of the fluid to diverge from the point AB. When a gas or fluid is expanding, divergence is positive. When it is compressing, the divergence is negative. The fluid is said to be incompressible if divergence of f is equals to 0. So just remember these terms. So if your curl is 0, then it is called irrotational, because there is no rotation of the pedal considered at a point. Now the divergence, which is also called flux or flux density, divergence means the tendency of the fluid to diverge from the point A, B when the gas or fluid is expanding. Divergence is positive, and when it is compressing, and divergence is negative when the fluid is negative. And when it is compressing means that it is like squeezing, and the fluid is said to be incompressible if your divergence of f, this is equals to 0. Once again, another important identity, we have understand that curl of grad f equal to 0. Once again, divergence of gradient of divergence of curl f is also 0. Divergence, we will denote it as using this nabla dot sign. Okay, then divergence of curl f is equal to 0. So divergence curl f is actually, this is equal to 0 due to Clairaut's theorem. There is no necessary, this is just, you just break it and you will get it. So divergence of curl f is also 0. So you need to remember these two things, that curl of grad f equal to 0 and divergence of curl f is also 0. Now divergence of grad f is called the Laplacian. Divergence of grad f is called the Laplacian. This is also one important term. Now this is called Laplacians, means if you are operating on a scalar potential, scalar function f, you are operating first the gradient operator, then you are operating the first you have used the gradient operator, then if you are you are using the there is a typo, do not, this is not, there should not be this, just forget it. Okay, that will be divergence of grad f, that will be small f. Okay, I am writing this, just this will be small f. Excuse me. So that will be small f. I have also stated Green's theorem in vector form. There is no need to remember it. You just read it, you just go through it, you can actually understand it. So this is Green's theorem in the vector form. This is Green's theorem. This is f dot n cap ds equal to divergence f dA. This is called tangent form. There is the first form called tangent form, the second one is called normal form. Now there is one important question, that surface area of solid of revolution. Sorry, I need to so I hope that you are getting familiar to these concepts about surface area of solid of revolution and all. So suppose a smooth curve is given by y equal to fx, where fx is greater than or equal to 0. Its arc when a is less than or equal to x, less than or equal to b, is revolved about the x-axis to generate a solid. How do we compute the area of the surface of this solid? Okay, so this is our query. Suppose you have a smooth curve given by y equal to fx. Your fx is greater than or equal to 0. Its arc when a less than or equal to x, less than or equal to b, is revolved about the x-axis to generate a solid. How do you compute the area of the surface of the solid? Okay, just see, this is the dholak like shape. It is a dholak like shape. This dholak like shape. So this is the arc. This arc is moved around the x-axis. Now we are to determine the area of this dholak surface. There is a lot of mathematical calculation in it, but we will mostly track the we will just follow. So notice that with relevant limits of integration, if the revolution is about x-axis, then your answer will be, the surface will be 2 pi y ds. ds is the arc length. You know arc length, 2 pi y ds. Okay, and if your rotation is y axis, that will be 2 pi x ds. I am giving you 2 to 3 minutes. Just read this statement. I will not go through the derivation part. I will upload the note, and from the note you can actually go through the build up on the process, that what is the process is there. Okay, so I am just giving 2 to 3 minutes to you. Just read this only this section. Okay, so dear students, first of all, apology to all because I was bit late today in the class, because there are some fest going on in our institute and there were too much noise, so I could not start the class on time. And once again there will be some DJ night is going on just behind our hostel campus, so there may some noise may come, so please I apologize for that inconvenience. Okay, so next next we will move. So you need to find the surface area of the solid that is obtained by revolving about x-axis. The arc of the curve is y equal to 2 square root of x. So 1 less than or equal to x less than or equal to 2. Since y is equal to 2 square root of x, your dy dx will be 1 by square root of x, and square root of 1 plus dy dx whole square, that will be square root of 1 plus 1 by x. Then your answer will be s, the surface area will be s 1 to 2 pi y 1 plus dy dx whole square half dx equal to 1 to 2 pi into 2 square root of x square root of 1 plus 1 by x, and then you need to integrate it. See, this square root to x, this square root of x will vanish, right? So in the above term you will get only x plus 1. So 4 pi into square root of x plus 1 dx. Then you just need to integration, and you know better that how to do integration than me, I hope so. So this is the just a very simple problem. Okay, very simple problem. So I am just giving you 1 minute to 2 minutes, just observe that what we have done here. You have the y equal to 2 square root of x, and you have 1 plus dy dx whole square to the power half dx, 1 2 pi 2 square root of x square root of 1 plus 1 by x dx, 8 pi by 3 root 3 minus 2 root 2. Next, you need to determine you have the arc of the parabola y equal to x square is revolved around 1 less than or equal to x less than or equal to 2 is revolved around the y axis. Find the surface area of the revolution. The curve you can parameterize as rt equal to xt plus yt j cap 1 less than or equal to t less than or equal to 2, where x t is equal to t, y t equal to t square, x prime t equal to 1, y prime t equal to 2t, then x prime t equal to 1, y prime t equal to 2. The surface area is s equal to 1 comma 2 to 2 pi xt. You need to follow the formula just. So this is square root of, so x prime t whole square plus y prime t whole square dt 2 pi 1 comma 2 t square root of 1 plus 4t square dt. So that will be pi by 4 1 to 2 square root of 1 plus 4t square d of 1 plus 4t square. I have just adjusted it. I hope that you get it right. 2, so this will be 8t, like 80. So you have t, you just need to divide it here by 8, and that is how you can just next pi by 6 third bracket 1 plus 4t square to the power 3 by 2. This is varying from 1 to 2, and if you just solve it, you will get this answer, pi by 6, 17 by pi by 6, 17 square root of 17 minus 5 root of 5. Okay, I am just giving you 2 to 3 minutes. Just whatever this here we have used, you just need to follow that. Okay. Next, the circle of radius 1 center at 0, 1 is revolved about the x-axis. So you have circle and your circle is like revolved like this. So you will get a torus like structure. So it's revolved about the x-axis. So circle of radius 1, that's mean parameter is, first of all, it will be cos t plus cos t and sin t, right? And this is centered at 0, 1. So y will be shifted by 1. T is varying from 2 pi. This is around x-axis, so you will be 2 pi y, and this is x prime t whole square plus y prime t whole square. So that will be once again 1. So this is just dt. Okay. So we have used the parametric representation, and then this x prime t y prime t we have determined x prime t whole square plus y prime t whole square equal to 1. So thus the area of revolution is 2 pi y. So y is 1 plus sin t and your dt. So sin t, if you just integrate, you will get it 2 pi, and that will actually cos t, and cos t if you integrate 0 to 2 pi, it will be just like 0. It will be just like 0. So only thing you will get it as 2 pi into 2 pi. So that will be 4 pi square. Next, surface area. There is one important concept called surface area. As we know, a smooth surface can be given by a function such as z equal to fxy. More generally, a smooth surface is given parametrically by x equal to x u comma v, y equal to y u comma v, and z equal to z u comma v, where u v varies over a given parameter domain. Normally we say that the point u comma v varies over a domain in uv plane. The parametric equation is also written in the vector form as r x u comma v I plus y u comma v j plus z u comma v k cap. So that is like just sphere. Okay, तो sphere का क्या होता है? If you have a sphere having radius a, then the sphere will be the parametrically represented as a cos theta sin phi, a sin theta sin phi, a cos phi. A cos theta sin phi, a sin theta sin phi, a sin a cos phi, a cos theta sin phi, a sin theta sin phi, a cos phi, where theta is varying from 0 to 2 pi, phi is varying from 0 to pi. Similarly, if you have a cylinder, the cylinder you can also parameterize as a cos theta, a sin theta, that has you have know the radius is just a cos theta, a sin theta, and the z axis will be just z. this calculation is very tedious. Even in fact in our bachelors, when I have first learned these calculations, it was really like it was very awful, and the experience is not good for like. So I also request you to please just go through this, because it is very difficult for me to just read out and explain the things in online mode. Of course, if it was all offline, I could have used board and all. So I will just discuss one problem today, okay, about this. I will not follow this. So how to do this? So you have a surface area of the part of the surface z equal to x square plus 2y that lies above the triangular region in the xy plane with vertices 0 0 1 0 and 1 1. Zero zero 1 0 and 1 1, and you have x square plus 2y. So now this triangular part, this you can parameterize as using two part. There are two ways to parameterize it, but I will go with the just one. You can just consider the opposite one and also parameterize. So for example, so what we are considering here, x I am varying from 0 to 1, y I am varying from 0 to x. Simple. Also you can like just consider y from 0 to 1 and x varying from y to 1. That is also okay, but I will go with this. X varies from 0 to 1. And what is your fxy? X square plus 2y. Now you know this formula, area of S. You have the domain, okay, you have your function f, f is x square plus 2y, and this is your formula, f square x plus f square y plus 1. So f square x is 2x whole square plus fy is actually plus 2 square again plus 1 dA 0 comma 1 to 0 comma x square root of 4x square plus 4x square plus 5 dx dy. Now you need to integrate it. So those who are joined in online, I request you to please just do this integral. So whatever I have done, is it clear? I hope that it is clear till now. Like, because there is nothing very difficult in this formula. Just you have f, you have to calculate fx, fy, and just you need to integrate. I am just giving you 2 to 3 minutes just to digest whatever I have done till now in this problem. Just carefully look the problem. Okay, now it is also a bit tough one. You need to calculate surface area in generalized form. Recall that for a surface S which is given by fxy equal to z, the surface area is this d square root of f square x plus f square y plus 1 dA. Here d is the rectangle on the xy plane obtained by projecting S onto the plane. Look at this surface as fxy minus z equal to 0. So what you will get? Grad f. So grad f is fx I cap plus fy j cap minus 1 k cap. If p is the unit normal to the projected rectangle, then p cap is equal to k cap, because you are in the xy plane. Then you take this p must not be 0. Now you have this which is the integrand in the surface area formula. Your warning, this must not be 0. Okay, so a derivation similar to the surface area formula gives the following. Let the surface S be given by fxyz equal to c. Let R be a closed bounded region which is obtained by projecting the surface to a plane whose. So what is happening here? You can your fxy is explainable, right? Expressible in terms of z. You can determine z in terms of xy, but here it may not be possible that you are able to determine it. Okay, so that's why we need this general formula. So you need then I will solve a problem. Say you need to find the area of the surface So you need to find the area of the surface cut from the bottom of the paraboloid x square plus y square equal to z by the plane z equal to 4. Surface S is given by fxyz equal to x square plus y square minus z equal to 0. So you need to project it on xy plane to get the region R as x square plus y square less than or equal to 4. Your grad f gets it as 2x I cap plus 2y j cap minus k cap. Grad f is equal to 1 this. So now you have you need to determine this p vector. P vector is k cap to grad f dot p. So that is this will you will get it as 1. Next this is 1 plus 4x square plus 4y square dA. This you have projected it on the circle. So circle is varying from r cos theta 0 to 2, theta angle is 0 to 2 pi. This is square root of 1 plus 4r square r dr d theta. So that is pi by 6, 17 square root 17 minus 1. So if you just perform the integration, you will get it as 0 to 2 pi 0 to 2 square root of 1 plus 4r square r dr d theta equal to pi by 6, 17 square root of 17 minus 1. So I'm just like giving a few minutes, just read this out. Okay, just I am giving 4 to 5 minutes, just read this out. Okay, so this is now find the surface area of the cap cut from the hemisphere x square plus y square plus z square equal to 2 by the cylinder x square plus y square equal to 1. The surface projected on the xy plane gives R as the disk. X square plus y square is less than or equal to 1. The surface is fxyz equal to 2, where fxyz is x square plus y square plus z square. So what is grad f? Grad f is 2x 2y 2y 2z k cap. What is modulus of grad f? Grad f, absolute modulus of grad f is 2 square root of x square y square plus z square. So that will give you 2 square root of 2. Now this is your, what will be your p cap? Your p cap will be grad f dot p vector into k cap. So that will be modulus of 2z. So thus the surface area is 2 square root 2 divided by 2z dA, and this 2 root, this is z inverse dA square root 2, and according to the formula this z is nothing but 2 minus x square minus y square. Because how? Because how you can you say that this z, how this z becomes there is a typo, that will be minus 2. Okay, 2 minus x square minus y square to the power minus 2. Now you use substitution, x as r cos theta, y as r sin theta. 0 is less than or equal to theta less than or equal to 2 pi. 0 is less than or equal to r less than or equal to 1. So your surface integration is becomes square root of 2 0 to 2 pi 0 to 1 r dr d theta by square root of 2 minus r square. So the final answer will be 2 pi into 2 minus root 2. So I am just giving you a few minutes just before wrapping up the session. I am just giving you a few minutes, just go through quickly this whatever calculation I have done till now. Just watch carefully whatever calculation or whatever I have done till now. I do not think that I will be able to continue the class because there is some loud music is going on just beside here. It is creating great problem. So thank you for joining and staying with me. Thank you very much. Thank you very much for joining with me, and I hope that you will watch these videos again and again. So next class, in the next class we will discuss about integrating over a surface. And okay, bye. Thank you very much. Thank you.